Hello, everybody, and welcome to the CIRCit webinar series. How can digitalization and smart technologies help in the transition to a more circular economy? What are the opportunities that we can explore? And what are the challenges that we might encounter along the way? In the webinar today, we will provide a number of insights into the smart circular economy, which has been one of the key focal areas in our CIRCit project. CIRCit is a Nordic project which aims to support manufacturing companies in the transition from a linear to a circular economy. Over the last 3.5 years, we have involved more than 70 different companies and organizations in the co-development and implementation of a number of different tools and approaches covering business model innovation, sustainability strategy, closing the loops, product design, and also the smart circular economy. A little bit about me. My name is Daniela Pigoso. I'm an associate professor at the Technical University of Denmark, and one of my key research topics is on circular economy. I've been one of the co-leads of the CIRCit project, and today I'm here to have a more facilitating role. Our workshop will take about half an hour, and our main goal is to provide an overview on how to take advantage of those digitalization technologies such as the IoT and big data to support this transition to a circular economy. And for that, nobody better than Eivind Kristoffersen, who is a PhD researcher at NTNU, the Norwegian University of Science and Technology, that has been one of the key partners within the CIRCit project. So many thanks for being here today, Eivind. We are all very much looking forward to hearing more about the smart circular economy and also the key results in the project. Thank you very much.
As we don't have too much time here, I'll be quite pragmatic. I've opened up and downloaded the Smart Circular Economy workbook here. I'll run you through parts of it here. What's worth noticing before we get started is that the Smart Circular Economy focus area is a bit different than the other focus areas in the CIRCit project. Hence also the workbook is a bit different. We set out with a target in the beginning of this project to be quite pragmatic and detail a step-by-step approach on how to basically implement smart circular economy. But what we found is that essentially digital transformation for circular economy is so new and quite emergent that we needed to take a step back first to look at what are the mechanisms of understanding how digitalization and digital transformation and all these technologies can really enable the circular economy, to understand the mechanisms and the relationship behind there first. Hence, we in the workbook here, we have in part 1, we have dig a bit deeper into the, call them building blocks or technical mechanisms behind the smart circular economy. And also the data science process, which we will showcase a bit. Then we have 5 different cases of examples of smart circular strategies for the companies we have worked with throughout the CIRCit project. For all the different workbooks, we have a general introduction to circular economy. Then we also present the circular strategy scanner, which is the circular economy framework we have used throughout the project here. And when we talk about the smart circular economy or the digital circular economy, the sort of the end goal and the vision that we want to strive for at large is essentially to connect the material flow with the information flow. And there, essentially, when doing that, you want to obtain information from all the way from materials are being sourced, from resources are being obtained, to when they're manufactured, when they're used, and to reuse and recycle. And then for each step there in the current model and the current economy, we have a lot of gaps in knowledge and information about each step there. And there's a gap in the information and data for that particular step for it to scale, basically. Therefore, that strikes to the core of where we think that digital technologies can really help leverage circular economy and the transition for companies. So companies can absolutely implement many of the strategies that we see here, but they will have difficulty with scaling it or making it into a competitive advantage. When we look at these strategies, the ones in the middle here are basically operational strategies, whilst the one on the top on the side are more strategic categories. So if we take one example, if a company wants to go from making products and selling products to providing that as a service, either through a usage-based business model or a performance-based business model. In the first case on the usage, they need to know essentially where are their assets and their products, so tracking and tracing, and also the availability of their products. That's particularly where IoT could help in the first instance. Then if you want to take that one step further and create a performance-based business model, you need to know how is the asset actually performing, what is the results it's generating. Then you need some more insights on this usage and on the data and analytics in particular. This is where then AI can be brought into the table, and that's also where then it's essential to know what is the condition of that product, what's its use and the wear and tear and degradation of that product and its materials. That's also where you have connections between here the more strategic strategies and the more operational, for instance, for repair and maintenance and predictive maintenance, which we will showcase afterwards. This is also knowing the condition is very important if you want to make that product loop several times and get the products and have a buyback scheme, and then know what is the condition of that product, how has it been used. This is quite important. If we then jump further down here into the actual smart circular economy, in the figure here you can see the main digital technologies that we have focused on here. Essentially IoT, big data, and AI. And as can be seen here, there's quite an overlap here. Thus, we try to abstract away a bit from the core digital technologies and not only focus on how do you implement IoT physically or set up a big data infrastructure. We try to look at the mechanisms behind there. So in the first instance, you need to have a data collection strategy, and if you don't have any data, there's not much you can do afterwards there in this regard. Then second, you need to integrate that data with other sources and also ensure and validate the quality of that data for it to be trustable later on. Then for the data analytics, this is essentially then where you connect AI. You don't have to jump directly into AI. You can also, in the first cases, go for statistics or some reliability analysis to see how is a wear and tear of a particular product, for instance. Then acknowledging that no companies can essentially adopt and implement circular economy alone, you essentially have to share data. So if you remember that connecting the material flow with the information flow, you really need to share data between different stakeholders. Essentially, particularly in Nordics with a lot of SMEs, where they don't have overview of the whole material flow. So we need to share information there. This is quite difficult when it comes to trust and transparency in an IP, but new technologies such as blockchain can offer some support there in order to increase the trust and transparency. We're not focused on that here, but it's particularly important to create those networks and collaboration. What's behind here is also the data-driven culture in general, where by that we mean essentially that managers and for the culture in general, they value the insights and information obtained from the data, and they use that in their decision making. So they don't only use their gut feeling or their experience when making a decision. They maybe more times than others rely on analytics and the insights generated there. Then it's very important to know how the data has been procured, how it's been processed, in order to trust that the quality of that data and the insights are true, and you can then leverage your decision-making support upon that. Then if we look at how companies are actually implementing this, we see that we've detailed here an analytics ladder from descriptive analytics to figure out what happened, all the way up to predictive and even prescriptive analytics to figure out what will happen and how can we optimize what will happen. Then you essentially need to build upon and leverage the different building blocks, and also think about all the essentially organizational resources that have to be allocated in order to enable that. We see also a connection here. Essentially, once you progress upwards here, there's an increasing ability to support or unburden human decision making. And we see a connection there between basically increasing automation or digitalization and the potential for increasing the resource productivity. So companies that are quite mature in the digital realm, they have a quite strong potential to leverage that for circular economy gains and increasing their resource productivity. Parts of the reasons here are that it's if you're higher up here, you have a greater degree of flexibility on your decision making. Some of the decision making are more optimized, and some of it also can be then put to other uses to abstract a bit up and leverage more on system thinking, for instance. If we take these same 5 steps here and we look at the different smart circular economy strategies, the examples we have here. So 3 examples here from industrial symbiosis, maintenance, and recycling. For the maintenance example here, we can see that in general, there's a less need from the digital technologies here. One example here is reactive maintenance. So it's essentially where you can put an IoT device on a product and then figure out whether it has failed. So it can trigger a request for repair based on sudden alert of failure. And then if you take that upwards in the maturity, you can eventually bring in the condition monitoring and even predictive maintenance or prescriptive maintenance to estimate what is the wear and tear and the remaining useful life of that product, and predict when you should have an optimal maintenance window to not find that sweet spot where you're not maintaining too often, so you're wasting resources, but not too late as well, so it's degrading too much. To both to reduce downtime. This is also all the information you gain here is quite important also for other strategies. If you want to then refurbish this product or remanufacture it to second use, you need to know how has it been used and basically the condition of that product. What's detailed here is the data science process. This is building upon one of the most well-known data science processes called the CRISP DM, and we've added analytics profiles and data validation. I'll not go into depth here for each level, but essentially the 2 phases I want to stress the importance of is the business understanding and the data understanding. In the first instance here, it's very important to understand the problem at hand, both talk with domain experts and also in this case particular understanding the circular economy impact and potential of a particular solution, and then really work with the data scientists in the data understanding what is the data needed for here. Maybe we don't have enough data, we should collect some more data, find the appropriate KPIs that are both doable, that have a goodness requirement for how to assess and evaluate whether that new analytic solution is working, but also understanding the circular economy impact of it. So we explained this process, and for the second part of that workbook, we're taking those same 5 levels here And we have showcased where we have 5 different example cases from the companies we work with. So ranging from predictive maintenance to on knowledge discovery. That's the case where companies, for instance, have collected a lot of data over many years that has not been put to use yet. So we're then implementing data exploration techniques to figure out what are the insights, what are the informations or the knowledge we can obtain from that data. Then we have one case on anomaly identification and one case on identifying sensor fails and false alarms. So for each case here as well, we have then detailed how long we went through the different steps, how many steps we analyzed here on the data science process, what are the lessons learned. For some cases also we went further and also actually developed some new analytic solutions. With that, thank you.
Thank you very much for a nice presentation, Eivind. We do have some questions for you, so let's start straight away into the first question. That's about what can companies do if they have little experience in implementing digital technologies? Where to start? Do you have any recommendations in relation to that?
Yep. A lot of companies, they typically want to also almost jump directly into the more advanced analytics. So jump directly into predictive maintenance and try to for those higher levels of that ladder. Whilst then also, okay, we want to implement IoT and use AI, these new fancy deep learning methods. And oftentimes they forget one of the most elemental steps in the beginning there to first get a grip on your IT infrastructure. And also at the same time develop the organizational resources that is needed to support eventually a predictive maintenance strategy or a predictive strategy when you're then predicting what will happen. But if you don't have the organizational culture to really take those insights and use them for strategic purposes, for competitive advantage, or in this case, particular circular economy impact, then those strategies are almost left alone in the toolbox, so to speak. So taking a look and then trying to at the same time transform your organization to value the insights generated from data. So start simple, start small, look at the data and the technologies you already have at hand. Maybe don't jump straight into IoT. Look at maybe we already have some data in the machines operating in our manufacturing facility that has been there for a lot of time but just not used. Maybe that's can be quite efficient way. So there's definitely some low-hanging fruits here that if you make a good assessment of what our current situation and then try to map what are our future targets. That also comes back to a bit about what some of the future work we have, which we also launch here on the CIRCit website. It's the Smart Circular Economy framework, which enables you to make that gap analysis on what is our current status, where do we envision to go, and then what are the requirements in order to get there.
And if we try to think about this transition going from where we are today to where we want to go, could you maybe mention what are the typical barriers that companies face when implementing smart circular strategies?
Yeah. One thing that I might hear quite a lot is the lack of data quality. So when striving for some of the more advanced solutions here on predictive or prescriptive analytics, the data foundation is oftentimes not there for companies. So typically have two types of companies. One company that has been collecting data for many years. They have an abundance of data, but they don't know what to do with it. And on the other side, you have companies that have not collected any data, and then they're slowly starting. So for the first instance, such a company that oftentimes they have not then collected that data for a particular purpose for doing predictive or prescriptive analytics. So, for instance, in maintenance, to implement predictive maintenance, you need not only to have a lot of sensor data, but also couple that with service and maintenance logs in order to know when the component was maintained, in order to find when it should be maintained. So oftentimes that is missing, and hence also the quality of the data, even though there's a lot of data, is not there yet. For the other type of company which has not collected any, I would also then advise to try to make a first loop of that data science process. Start small, find one particular strategy that might be not too complex, and then make one round and to check also whether the data you have collected is of high enough quality. So that's some of the thoughts there.
Thanks for that. You also mentioned during the presentation about the need of implementing circular economy with a number of different companies at the same time. And sharing data in this context is extremely important. And we have a question here regarding data privacy and security. Is that a problem, especially when companies reach the more predictive stages in your letter? And how are companies dealing with that?
There's definitely a lot of privacy and security challenges when implementing these technologies. Oftentimes also, if you have one data set left alone, cannot be on its own. It's not posing any privacy issues, but if you couple that with other sources of data and integrate it, then suddenly you can identify a person. Then it is a privacy issue. A lot of times companies they see security and privacy as a big barrier. Highlighted by some of the companies we worked with, they might turn that upside down and look at it as a possibility in order to compete with bigger players, as treating then the end customer as essentially a positive player that can choose sort of which vendor they want to share the data with. And then as a lot of incentives for companies to implement sustainability and circular economy is also to have a well-known, get a good reputation. So combining those there, that treating end customers, consumers as a positive player that can then choose your company that might have a good sustainability or circular economy strategy over another company that do not. And then having that targeted sharing on the privacy and security challenges might be a potential for companies to compete with bigger players. So there's it might be a competitive advantage to be gained there as well.
Got it. Yeah. Thanks for that. The next question that we have tries to connect smart and sustainable. And the question is whether is there any approach to select the right mode of digitalization so that we can create more circular solutions, but also more sustainable solutions at the same time?
It's great question there, and it's definitely not an easy one. That's also what we apologies, try to target at here. I think it's important to first of all figure out what does sustainability and circular economy mean for your company in particular, as the answer here will depend very much from company to company, from product to product. So making a good screening of what is your essentially circular economy targeted strategies in the first case, and then really working with them, and then taking a systems view and maintaining that system thinking throughout when we implement these digital technologies, as we can see that essentially the digital technologies can support and burden human decision making. So that gives flexibility. and it, as detailed in the figure as well, it has a potential for resource efficiency and product productivity if it is put to the right use. So definitely, in the first instance, having a good circular economy strategy and objective.
Great. And we have time for one final question, that it's about estimating the effort required to adopt digital technologies. Are there any existing methods that can help companies in doing those estimations?
There's not to my knowledge any on how to implement them for circular economy and estimating what are the required effort there. Digital transformation and digitalization in general, I reckon there must be a lot of well and good tools that can help you assess that. We have one tool coming up that will be launched at the CIRCit website called the Smart Circular Economy Framework, which gives you part of that picture. It helps you facilitate what we call a business analytics gap analysis. So it helps you evaluate what are essentially your current status if you're at, for instance, the descriptive or discovery level, and then what are the requirements if you want to target for a particular strategy for maintenance or industrial symbiosis at a high maturity level. So then one can see the requirements from the digital perspective, and also then look at what are in the long run, what are the cultural changes, the organizational resources you have to obtain in order to leverage that strategy. So maybe you're lagging in the cultural aspects, you're fine in the digital, or the other way around.
Great. Thank you very much for that, Eivind. So we just need to keep looking to the website, and soon the tool will be available there. Thanks, Eivind. Before saying goodbye for today, I just want to make two invitations to you all. The first one is about our webinar tomorrow, Thursday, also at 3 o'clock in the Central European Time. Jutta from the RISE Institutes of Sweden will be here with us tomorrow to share some insights about how to close the loop for a circular economy. We all know that there are several different strategies that we can implement here, such as remanufacturing, reuse, refurbishment, or recycling, for instance. But the biggest question here is, how can a company, after having taken back their products, define what is the best strategy to be implemented? Should we recycle this given product, or should we maybe remanufacture that? Tomorrow, you're going to have access to a decision tree that helps in this decision-making process and brings up some key strategies to focus on. So I hope to see you tomorrow. And the other important invitation I have to make to you is about a workshop that we will carry out here in Copenhagen in September. We will possibly also have hubs in all the other Nordic countries, so Sweden, Norway, Iceland, and Finland, where you have the chance to try out all the different tools and approaches from the CIRCit project in a very hands-on activity. If you have the interest to join, I will add the link into the chat box, and you can pre-register so that we can send you more information in due time. Great, so that was all for today. Thank you everybody for coming, and I hope to see you tomorrow. Thank you.